Okay, today we're going to take that next step. I'm actually going to try something. So let's see if I put this over here if we can actually hear the recording. The last couple times it's not coming out the greatest. We'll see. No, it's because I have to project to get to you guys. And when I project, the way it was picking it up when I was holding it closer kind of overwhelmed the mic. So we'll see if this works better. If it doesn't, I'll just re-record it next period. Today, we're going to take that next step. We've been doing expressions for, seems forever. Quite honestly, it's been almost a month because of spring break. So we're going to move the next step. The nice part is this isn't that big of a step because what we're going to be doing with writing equations, you've already got your basis because of writing the expressions. Why is that? Well, let's talk about some definitions. That's going to help you understand why. What is an equation? What is the verbal definition of an equation? Devin?
An equation is a math problem including any amount of terms with an equal sign.
Good. I like most of it. I'm going to cut it down a little bit. We're going to say it's a mathematical sentence with an equal sign. Now, that being said, it does include or can include operations, numbers, variables, in any combination. But one big key in an equation, I've got an equal sign. Now, the other side, you can't see it below this, but it says expressions. What does an expression? What is that verbal definition? We've given that to you before because we did expressions. David? No, he's saying, I wrote a sentence, so I should have a capital A. Woo! There we go. This is really kind of fun.
No, it's really not. It's one word.
It's so fun. There. Just for David. So what's our verbal definition of an expression? John? A mathematical. Actually, I'm gonna go instead of saying mathematical sentence because a sentence is a complete thing. We're gonna say half of a mathematical sentence. In other words, an expression is what you would see on one side of an equal sign. You just don't get both. So what do I mean by this? Let's look at some examples. If I'm using a numerical example, it would be something like 6 plus 4 equals 10. That is an equation. If I want to put in a variable, I could say something like 4x equals 24. Key being, I now have the equal sign. On the other side, an example of an expression, if I had just a numerical expression, it could be something like 2 plus 7. Or, for an algebraic, we could say something like x divided by 4 equals 24.
Oh, that's wrong. You put equals 24.
Oh, thank you. Actually, Devin, I was going to try to trick you on that one. I was. Because I was going to ask you what x equaled in that case. But with an equal sign, I could. David.
I'm a restart. Yes, friend.
David is really trying to get on the recordings today for some reason.
Hello.
Okay, how are an equation and expression similar?
They both have numbers.
I know.
How are they similar? They both have numbers. What else do they have? So?
They have mathematical signs.
What do we call those?
Plus.
Addition.
So what do those represent?
Term.
What would I use for one word that covers all those things?
Mathematical symbol.
Math.
The mathematical symbols represent what?
What you do in that thing. Yes.
The equation.
Order of.
Operation.
Okay, so it's going to have, they both have numbers and or variables. They don't have to have either. And operations.
Make sure you put a capital N period.
Just for David, before you could say anything.
Really? That's all you could think of? They both have numbers?
Okay?
Well, you didn't say
Now, how are they different?
One has an equal sign and the other doesn't.
Which one?
Equation has an equal sign.
Good. An equation has an equal sign. Is there any other difference? What? Do you have to answer it? No.
It's okay.
So, we've got a whole bunch of, today we're going to be writing equations. You don't have to solve it unless it tells you to. No? You have to follow directions, actually, David. Something you struggle mightily with since you're one chair lean from losing your chair today. Okay, when I replace, okay, here's what we're going to talk about. Determine values that make your equations true. When we say we want our equation to be true, that's what you instinctively do with equations. In other words, you find the value that you look at it and say, oh, okay, that's true. Normally, though, you say, when you replace a variable with a value that results in a true sentence, you solve the equation. That value for the variable is the solution of the equation. Because it makes the equation true.
5 more minutes.
So we're going to introduce you to one of the standards of mathematical practice. One of the things that we allow you to do in order to solve problems is a process called guess and check. This is actually one of the initial ones that you can do. A lot of it is based on numerical number sense, how well you understand numbers and how well they fit together. So people like Isabella, this is one that works really well because she is very instinctive in her mathematics. So for example, if I say 2 plus x equals 10, what value would I put in for the x to make that true?
8.
8. So I would say 2 plus 8 equals 10, because then I would add it up. 2 plus 8 is 10. 10 equals 10. So the solution to the equation is
True.
x equals 8. Make sense? So really, when I say solve the equation, I'm saying what makes it true. In other words, when I look at it, I say, okay, yeah, both sides of the equal sign are the same. That's now true. I've solved the equation. What about this one? Now we're looking at multiplication. We're saying 18 equals 6 times some number. What value do I put in? 3. So 6 times 3 is 18, so the solution to the equation is
X equals 3.
there. You getting it? Okay. Now here's one. I know you guys are going to hate this. I will go ahead and admit up front I'm not the greatest fan of it, but it's part of the learning process. So we're going to have you do it. Part of the guess and check method is we want you to understand it's okay to be wrong in your guess. So what you're going to do is use a certain value of numbers. You're going to check them all even after you find the true solution.
You hate that?
I do.
Guessing for our homework.
Once I find the true, why do I need to keep going?
Yeah, what?
Because there's no point. Our homework is to guess.
That would be nice.
So all I'm going to do is substitute for our variable c all of these values. So what we do is we just rewrite this. We say 4 plus 7 equals 13. Then I add it. 4 plus 7 is 11. Does 11 equal 13? No, so that's false. Then I do the next one they gave me. 5 plus 7 equals 13. 5 plus 7 is 12. Does 12 equal 13? No. Then I do the next one. 6. 6 plus 7 equals 13. 13 equals 13. Check. So now I have my correct solution, and I know that C equals 6 is my solution. Make sense?
You have to do all of them?
If they give you 3 of them, yes, you have to do all of them. If they give you 8 of them, you have to do all of them. If they say to check all of them. Okay, our next one, we're just going to do some mental math. 9 minus some number equals 2. What number do you think would go in there? 7, so let's try it. So 9 minus 7 equals 2. What's 9 minus 7? 2 equals 2. Check. So my solution is x equals 7. Showing you the examples on what you're supposed to do on these. Again, the big one being, if they show more than one number, we need to do them all. So our next one is where we're going to start getting into this translation. Just as we translated expressions from English to math, we're now doing equations from English to math. Just as in expressions, we followed the order that it was written in English. In equations, we follow the order that it is written in English. And we translate it to math. Okay? So our difference between this ostrich's speed and a chicken's speed is 31 miles per hour.
Pause for a second. If I find out who's tweaking their shoes, I'll email it to her. That's ridiculous. You have to stop one of that.
An ostrich can run at a speed of 40 miles per hour. Use your prior knowledge to solve 40 minus c equals 31 to find c, the speed of the chicken can run. So this is what we're looking for. This one is a little easier. I forgot they gave us the equation on this. So using our prior knowledge, if I do 40 minus c equals 31, what number should I put in for c to solve? So 40 minus 9 equals 31. 31 equals 31. Check. So we made a good guess. So we can now actually solve and say the speed of the chicken is 9 miles per hour. I'm going to abbreviate MPH. Make sense? So here's where Devin's going to have another conniption. I have 3 numbers. I need to substitute all of them in. So we do 4 times 2 equals 16. 8 equals 16. Is that true?
4 times 2 isn't 16.
Wow, shocker. That's the point.
That's why we said 8 equals 16. Does 8 equal 16?
No.
No, so that is false. So now we do our next check. 4 times 3 equals 16. Does 12 equal 16? No, that is also false. Now we do our third check. 4 times 4 equals 16. Does 16 equal 16? Check. So our solution is n equals 4. Solve 24 divided by w equals 8. So here's where we do need to write our equation. Again, we do it just like it's written in English. So 24 divided by w equals 8. What should I put in for w to make this a true statement? Okay, 3. So let's check it. 24 divided by 3 equals 8. Does 8 equal 8? Yes. So our solution is w equals 3. You guys getting the idea? Well, I hope so, because that's page 1 of our 4-page packet. So let's go ahead and turn to our second page. This one is your chance to start practicing what we've been doing. So I apologize. They give us 3 values. Yes, you must check all 3 values even after you find the true one, just to prove that the other ones are false. The bottom part here, I don't really like this, but because we're just introducing, we'll let you do this mentally. as we keep going, we'll start showing you how to actually solve these equations. So we'll give you guys, we got 8 problems here. We'll give you about 7 minutes. Okay, checking these should be very easy. Literally all I'm doing is substituting that value. So 7 plus 3. Well, if your pen works better than mine, it should be easy. 7 plus 3 equals 10. 10 equals 10. There's our check, so I know my answer is A equals 3, but I still check the other two. 7 plus 13 equals 10. 20 equals 10. That's false. And then we do 7 plus 17 equals 10. 24 equals 10. That is also false. Okay, our next one. We do 14 minus 9 equals 3. 5 equals 3. That is false. We do 14 minus 10 equals 3. 4 equals 3. That is false. And then we do 14 minus 11 equals 3. So I do 3 equals 3. There's my check. So my solution is M equals 3. 2 times 12. Wow, this side is really fritzing out today. Oh, thank you. M equals 11. That's what happens when I start trying to see what's not there. 24. Or if my board just starts doing this. 24 equals 24. Check. So we actually solved it on our first one. My solution is N equals 12. So we still check our other ones. 2 times 13 equals 24. 26 equals 24. That is false. 2 times 14 equals 24. 28 equals 24. That is also false. So we did find our one true solution. Our last set here. 32 divided by 4 equals 9. 8 equals 9. That is false. 36 divided by 4 equals 9. 9 equals 9. That is true. Sorry. True. So we actually have our solution, which is x equals 36. And then our last check. 40 divided by 4 equals 9. 10 equals 9. That is false. Using mental math, these ones should be pretty easy. 5 plus 7 equals 12. 12 equals 12. Check. So B equals 5 is my solution. 10 times 23 equals 230. 230 equals 230. Check. So my solution is S equals 23. 15 minus 3 equals 12. 12 equals 12. Check. So B equals 15 is my solution. And, excuse me, 36 divided by 2 equals 18. 18 equals 18. Check. So my solution was D equals 36. Yes. 36 divided by 2 is 18.
I knew that.
Okay, here's where we're really going to get into writing our equations. Again, try to follow this in the order that it is written, number 1. Number 2, your question will contain your variable. So 2 huge hints for you. So on this one, we've got an orange and a cup of juice are 210 calories. An orange has 90 calories. How many calories does a cup of juice have? So there's my question. So in words, this is basically just a way of restating what we're seeing here. So what am I doing? I'm saying an orange and a cup of juice. So what operation would that be? Addition. Okay. So if I add orange and juice, it equals what? 210. 2 keywords you need to add to your math vocabulary as far as things that you need to mark your text. The words are and is. Because now that we're writing equations, that is one of your key indicators for where your equal sign goes. So what is our variable? What is it we don't know?
How many calories do you have?
Good. So my x equals number of calories in a cup of juice. Yes?
Why would you go through the trouble of eating an orange and drinking juice? Why wouldn't you just drink orange juice?
Because it's actually,
Orange juice or you didn't have it?
oh, you want the exercise of peeling?
Oh, just drink the juice from the orange.
Let's focus in on writing the actual equation, guys. Again, we have to follow it the way it was written. So, do we know what the orange has for calories? What?
90.
90. So I know that the orange has 90. I know I'm adding. Do I know how many calories the cup of juice has? No, that's my variable. R, that's my equal sign, 210. Questions? Do I have to solve it? No. Could I solve it? Yes, but it didn't say to, so I don't have to. Yes, David?
If you say something about a capital letter or a period, you and I are going to step outside. You know.
Okay. Good. Okay, next one. This one actually gets really confusing, so we got to be careful on this. Lake Arrowhead State Park has three, there we go, 3 less hiking trails than Irwin Park. Lake Arrowhead has 5 hiking trails. How many trails does Irwin Park have? Okay, so in words, what are we saying?
Arrowhead State Park has 5 trails that Irwin.
No, don't get to that. Look at the top part first. The very first sentence.
Like Arrowhead has 3 less trails than Irwin.
Okay. What is so? How would I write that in words? What am I saying? Technically, in words, what I'm saying is, if I know Irwin Park, or EP Irwin Park, and I subtract 3, or add 3, has 3 less, no, subtract 3, then I find out what Lake Arrowhead Park has, right? Well, because I didn't want to write out all the words.
That's cheating.
No. It's having 3 minutes left in class. So what is our variable? What is it we don't know?
5.
What is it we don't know?
The amount of hiking trails that Irwin has.
Good. So my X is number of hiking trails in Irwin Park. So now let's write our actual equation based on the information they gave us. Lake Arrowhead Park has 3 less than Irwin Park, but Lake Arrowhead has 5. So how could I rewrite this? X minus 3 equals 5. Make sense? Okay, our next two I'm going to go a little bit quicker because we're almost out of time. We have 7 tickets to the Children's Museum, cost $35. How much does 1 ticket cost? So if I do 7 tickets, I know it's going to equal $35. What don't I know? Cost of 1 ticket. In dollars. Good job, because we need to be specific as possible, right? So our equation is 7 of those, 7x, is $35. Next one. Ground beef is being divided into 4 hamburgers. Each burger is 6 ounces. How many ounces of beef are there altogether? I'm going to skip the words on this one because I want to work on the variables and equation in our last 2 minutes. So what is it I don't know?
How many ounces of beef there are altogether?
Okay, so X is number of ounces of beef. We know that that is being divided into 4, and that it then equals 6. Make sense? Okay, so now let's look at actual real word problems. The Merritt River Center has a main roof height of 441 feet. With the additional height of antennas, the structure is 546 feet tall. What is the height of the antennas? So what is it I don't know?
The height of the antenna.
So my variable needs to be the height of the antennas. In feet. Okay? My equation, and again, try to follow what it says in English. So in English, first word thing I came up to was 441 feet. Additional height of the antennas. Additional height of the antennas is, again, that is one of your key words now, because that's telling me where the equal side is, 546. Is this making sense?
Yes.
Who feels like they're struggling on this part yet? Nobody? Good. Okay, I've got 1 minute to try to do this last problem. The average heart rate of a cat is 1/3 that of a hamster's heart rate. The average heart rate of a cat is 150 beats per minute. What is the average heart rate of a hamster? So what I don't know, oh, there's your bell. Guys, only do the last page of the packet. Don't worry about anything else. Okay? So it's just those last 5 problems.